One tip that I would like to give you based on my experience is cut off your fear. Don't think about solving perfect. When you actually practice, regular improvement will inevitably follow. Your brain accumulates data and lets you use it in the situation when it is needed. You need to concentrate solely on solving for some period of time and make time for it. And obviously, you can solve all of it together, but if you focus on just putting correct steps. And let's get into today's video on differential equations of first order and first degree. And the topic today is on homogeneous differential equations. So we are going to solve the differential equation x cube into dy by dx is equal to y cube plus y square into root over y square minus x square. See here, whenever it is an homogeneous differential equation, see here how to recognize that it is a homogeneous differential equation. See here, the variables are equally distributed. Here there are three variables here, and if you take the square out of this root, so there will be three variables here. Throughout the equation, the variables are distributed equally, and therefore I am going to write this in the form dy by dx is equal to, this is y cube plus y square root over, this is y square minus x square by, I am bringing this x cube down. See here, first the substitution here will be put y is equal to, see here, put y is equal to vx. So this is the substitution for homogeneous differential equation. If I make a derivative, so dy by dx value is equal to, so v into, for x it is 1. If I leave x, this will be dv by dx. So if I name it as equation 2 and this as equation 1 and substitute the value of 2 in 1. See here, substitute the values of 2 in equation 1. See, in place of dy by dx, I am going to write as v plus, see here, this is v plus x into, this is dv by dx value is equal to, in place of y, I am going to write as vx. So this is vx whole cube plus, in place of y, I'm going to write as vx whole square. So this is root over, in place of y, I'm going to write as vx, this is whole square minus x square. So this is divided by, the value here is x cube. The value here is x cube. So this value is v plus x into, this is dv by dx. So this can be written as, this is v cube into x cube plus this value is v square into x square, and this value is again, this is v square x square minus x square divided by, the value here is x cube. See, this we can write as x plus v plus x into, this is dv by dx value is equal to, this is v cube into x cube. So this is v square into x square. So if I bring this x square out, this will be x times of, this is v square minus 1 by, the value here is x cube. So if I multiply, this will be v plus x into, this is dv by dx value is equal to, this can be written as v cube into x cube plus again this is v square into x cube. So if I multiply these two into, this is root over v square minus 1 by, the value here is x cube. Now I am going to take this x cube common and cancel. So this is an x cube here in the numerator as well as the denominator. I am taking x cube common, and this can be written as, so this is v plus, this is x into, this is dv by dx. So if I take x cube common from the numerator, this will be v cube plus, this is v square, this is root over, this is v square minus 1 by, the value here is x cube. So this value is x cube. Now I can easily cancel these two and see here the remaining part, this is v plus x into the value dv by dx value will be, this value is v cube plus v square root over, this is v square minus 1. So next step what I am going to do is, I am sending this v to other side. So this will become x into, this is dv by dx value is equal to, this is v cube plus v square into, this is v square minus 1 minus v. And see, this is x into dv by dx value is equal to, this is v cube minus v plus v square into, this is v square minus 1. So now x into this is dv by dx value. If I take v common, this will be v square minus 1 plus this is v square into this is v square minus 1. See, I can write this as x into this is dv by dx. So v square minus 1 I'm writing as root over this is v square minus 1 into root over this is v square minus 1 plus this is v square into root over this is v square minus 1. Now I can take 1 v square minus 1 common among these, and therefore so this is going to become x into this is dv by dx value is equal to this is root over this is v square minus 1. If I take common, this will be v times of this is v square minus 1 plus the value here is, even I can take v also, and x into this is dv by dx is equal to v into root over this is v square minus 1. So if I take common, this will be v plus, so this is v plus I'm writing this is v square minus 1. And now what I have to do, so I have to separate variables and separables. So if I separate variables and separables, so here dv to one side and dx to another side. So this will become dv by, so if I send everything down, so this will be v root over this is v square minus 1 into the value here is v plus this is root over this is v square minus 1, v square minus 1. So here if I send dx to other side, this will be dx by x. So here what I have to do, I have to rationalize this one. So in order to rationalize this one, the step I'm going to take here is this is dv by this is v times of this is v square minus 1 into this is v plus root over this is v square minus 1. So if I rationalize with the negative term on both sides, so here this I am going to write as v square minus 1 minus v, and this value it is root over this is v square minus 1 minus v. So if I multiply and here I continue as dx by x, so this will become, see here this is going to become dv by, so here clear dv by this is v into root over this is v square minus 1. So here in the numerator if I multiply, this will be root over v square minus 1 minus v by this is a plus b and this is a minus b. So this will be a square minus this value is b square. So this value is dx by x. Now I can cancel these two and see this will be dv by root over this is v square minus 1 minus v by this is minus v into root over this is v square minus 1, which is equal to dx by x. So here, so if I separate each and every term here, so if I separate here, this will be root over this is v square minus 1 by the whole thing minus v by root over this is v square minus 1, and this is minus into minus plus this is v by, in the denominator this is v root over v square minus 1. So here dv and here dv, so which is equal to here dx by x. Now I can simply cancel these two and these two terms, and therefore what remains here, minus dv by, so here it is v and here it is dv by root over this is v square minus 1 is equal to dx by x. After simplification, so I am integrating on both sides. So if I integrate on both sides, see what happens here. So this will be, so this is minus log v. So this is minus log v, and this value is plus this is cos h inverse of v, which is equal to log x plus this value is log c. Or else there is another form here of writing, this is minus log v plus this value can be written as log of. So this value is going to become v plus root over this is v square minus 1, which is equal to this is log x plus log c. In both ways you can write, and see if I write like this, so this will be minus log v plus this value is cos h inverse of y can be written as, so v can be written as y by x, and here also y by x, so which is equal to, this is log x plus log c. And here if you observe this one, so this can be written as, so this can be written as, if you observe, this can be written as log of, this is v plus root over, this is v square minus 1, and if I send it to other side, this will be log v plus log x plus this is log c. This value is log c. And see, if I keep v value as y by x plus root over, this is y square by x square minus 1, which is equal to log y by x. So log a plus log b plus log c is equal to, so we can multiply all these and we can cancel these. So if I take LCM like this, log of, so if I take x as LCM, this will be y plus, this is root over, this is y square minus x square by x here, which is equal to log yc. So if I take log common, if I cancel log on both sides, this will be y plus root over, this is y square minus x square by x is equal to yc. So if I send this x to other side, see, if I send this x to other side, then the value here will be y plus root over, this is y square minus x square is equal to xyc, and this will be our solution. So if I take the value as this one, so here is another form. So if I send it to other side, so this value is going to become, this is the another answer, cos h inverse of y by x value will be, so if I send it to other side, this will be log of a into b into c, that is log y by x into c. If I cancel, this will be the answer. So this will be the answer as cos h inverse of y by x value is equal to this is log of yc. So this is one kind of answer and this is one kind of answer depending upon the formula. So here this is the formula, so these two are the formula for this is 1 by root over v square minus 1. If you take in terms of cos, this will be the answer. If you take the formula as a log, this will be the answer. So this is how we have to solve, and this is so simple if you follow these few steps here, and this is the most important question from the textbook. And see here, the first thing here is, as it is a differential equation, we have to transform it in the form of dy by dx, and again we have to substitute y is equal to vx and dy by dx as v plus x into dv by dx, and after putting second value in the first value, so this is going to happen, and we have to take x cube common and we have to cancel, and in the next step after cancelling x cube from the numerator as well as the denominator, so we have to send this v to other side and just we have to take v common here, and next we have to take root over v square minus 1 common, and after taking this common, so we have to keep variables and separables, so v to one side and x to one side. So here these v to one side, so as there is a root here, we have to rationalize here. So after rationalizing here and cancelling here, so we got this one. So after separating the denominator to each and every term and integrating on both sides, and we got the values as this one. So these are the two formulae which you have to remember, and simply we have to substitute again. So what is, so we have put y is equal to vx. So here if it is y is equal to vx, v value is equal to, this is y by x, and this is again the substitution. We have to transform in terms of x and y as putting v value as y by x. So this is y by x here, so each and every v can be shifted into y by x, and therefore we'll be getting the solution. Thank you so much for watching. If you really like, please watch each and every step, practice, and definitely you can solve by your own. And my next video will be also very important. I'll be uploading very soon, and pass it on to as many friends as you can, and go through the playlist, and your preparation will be damn easy. Thank you so much.